Good afternoon. My name's Ken Morris. I'm a captain on the Aluminum Overcast, the B-17G, that's owned by the Experimental Aircraft Association in Oshkosh, Wisconsin. This is Aluminum Overcast. You can tell by the nose art. During the war, most of the captains named their aircraft, and that was what was painted on it. They all had different names. This particular one was made too late in the war to see any service, which is probably why it's still around. But it got its name from a P-51 that was flying underneath it years ago, going somewhere, and he made the comment that it was like flying under an aluminum overcast. It is kind of a metaphor for the fact that in the European theater there were 600 and 700, even 1,000 of these things flying over at the time, so it truly was an aluminum overcast. We're going to show you the rest of the airplane and tell you a little bit about it. As we continue back just a little bit here from the aluminum overcast nose art, you can see this hatch here. This is the one that Gregory Peck in 12 O'Clock High had such a hard time getting into. I'm not going to demonstrate how these 20-year-old kids would throw their bags up in there and then swing up in there, because it would really be ugly. But this is where most of the officers got into the aircraft. The 4 officers in the flight were the pilot, the co-pilot, the navigator, and the bombardier. And they are all in this forward section. So this crew is pretty much for the officers to climb in and out of. You'd have thought for officers they'd have had stairs, but they did not. And this was also a bailout access if they had to bail out of the aircraft. Gregory Peck was trying to get in at 12 O'Clock High. He was trying to get in this door, and this propeller right here beside me was spinning. This number 2 engine was spinning, and you can see him trying to get in this thing with no props. It was pretty wild. Back here, this is ADF loop antenna, automatic direction finder. This is how they could pick up a radio beam from a certain station at a certain place and navigate to it with a pointer in the cockpit. It's not used today, but it's part of the static look of the aircraft. This is a B-17G, the last model that they built. Most of the B-17s built were G models. The most influential feature of the G model is the chin turret. The earlier models did not have this. The Germans exploited that by doing head-on attacks. They did not have any guns that could bring to bear straight ahead, because the belly turret, which you see back there, could not come forward because it would shoot the propellers off. That's not a good thing. So it was restricted from firing there. And also the top turret could not fire down enough because you'd shoot the pilots. And that's a good thing that they didn't have the ability to do that. So there was a little area here that needed some extra guns, and the chin turret took care of that need. The chin turret is operated by the bombardier. The bombardier has the bombing site and the famous Norden bomb site up in the nose, which we'll get to in a minute. But the bombardier is responsible for these 2 guns from his chair in the very front of the nose. All of the guns on this aircraft, there are 13 of them, are 50 caliber Browning machine guns. They each have 1 belt of ammunition, and the belt is, wait for it, 9 yards long. You've heard the term, give them the whole 9 yards. Each gun had 9 yards of ammunition. If you held the button down continuously, you would have a little over a minute of ammo left. It goes through over 700 rounds a minute, and that 9 yards is about 1,000 bullets. So they were pretty judicious about that. It's not like what you see in the movies where they just sit there and bang away. It was a couple seconds at a time. As we continue on around, so you can see the bombardier's chair up there. Please excuse all these bugs that are on this airplane are from Oklahoma. Texas didn't have any, but Oklahoma had all these bugs and they haven't been cleaned off yet. the bombardier's chair, and then the famous Norden bomb sight. The Norden bomb sight's that big black box right there. And over on our left, the bombardier's right, is a control wheel. The control wheel actually slid down in front of him, and he steered it like a car, and that's what steered these two guns here. So when he was doing guns, he was doing that, and when he was bombing, he was doing that. The Norden bomb sight was designed in the mid-20s. It was not nearly as exact and exacting as they would have liked to have you think. When they did the testing, it was in the mid-teens of altitudes, and they claimed that you could hit a pickle barrel with it in the 17 to 20,000 range. But in combat, they were flying at 35,000 feet, as much as 35,000, usually about 30 to 31,000 feet. The winds up there are terrific, and they really were not nearly as accurate as they would have had you believe they were. I like to say that they were usually able to hit the ground with the bombs. But if you have a 500 ship armada of airplanes, you're going to hit something somewhere. And the Norden bomb sight was super secret. They wanted to put fragment charges under them to protect them from getting into enemy hands. After the war, actually during the war, they found out that there was a German spy working in the factory. So all that secrecy was for naught. The Germans already had the technology. So the bombardier has control of the airplane during the bomb run, and he has through the autopilot, he has the ability to make small turns and make the airplane go where he wants. They have to stay in formation. He also has the ability to open and close the bomb bay doors, and of course to drop the bombs when necessary. Toward the end of the war, they ran out of bombardiers, and they started using enlisted men as bombardiers. They called them toggeliers. So they were enlisted, and they did not have the officer rating. I assume they still got in the same door that the pilots did, though. So we move around over here. We can see the cheek turrets. The cheek turrets were what was on the original E's and F models, but as you can see, they cannot come full forward. And the responsibility of those two guns is the navigator. They're staggered up there. If you look, one of them's further forward than the other, and so he could only do one at a time. He would take whichever one was the most important threat at the moment and fire at that, and then switch over to do the other one when he wasn't trying to figure out where they were. So that was the navigator's responsibility. We come over here a little bit in the shade, which is kind of nice, and we have the two holes in the leading edge of the wing. Those are for intercoolers for the turbochargers that are not well, they're actually installed, but they're not. We don't physically use the turbochargers because we don't have any reason to go up to 30,000 feet and find out that it's 30 and 40 below zero up there. I already know it is. So about the highest we ever go in this airplane is 12,000, and that's just to clear the Rocky Mountains when we need to from the west coast. The airplane, we'll talk about it later, does have superchargers, but the turbochargers are physically on the airplane because they're an integral part of the exhaust. However, we do not use them for extra boost that they use like they used them in the war. Those coolers blow air into the back of the nacelle, and that helps keep that whole assembly cooled because it's taking super hot exhaust air, compressing it, or actually compressing that and sending that up to the intake manifold, and it needs to be cooled. So those are all blocked off because we don't really need that air anymore. If we want to talk about some engines, we can do that while it's quiet for a second. These are Wright Cyclone R1820-97s. The R means it's a radial. A radial is a bunch of cylinders in a circle. Since it is an air-cooled engine, this is a clever way to get all the cylinders the same amount of cooling. It's a single row. What I mean by that is it's an odd number of cylinders with a single throw on a crankshaft, and there's a master rod, all the other rods, all the other 8 cylinders attached to the master rod and not to the crankshaft itself like it does on your car. A twin row, an example of that would be a Pratt & Whitney R1830, which was used on the B-24. The R1830 is a 14-cylinder engine. It's basically 2 7-cylinder engines put together, and it has 2 throws on a crankshaft. Without getting into a lot of detail, this 1820 is the largest single row radial ever manufactured, and it has 1,820 inches, cubic inches, which is what the next number on that means. So it's R1820-97. -97, I have no idea what that means, but it means 1,200 horsepower, and that's what it produces for takeoff. It is geared, supercharged, and turbocharged. The turbocharging we talked about already. The supercharger is an integral part of the airplane, an integral part of the engine. So it is always working, and we use it. We use usually 41 inches of power for takeoff. We do not use the 46, which is what the 1,200 horsepower required. 46 inches of manifold pressure and 2,500 RPM. We use 2,500 RPM, but we only use 41 inches of manifold pressure. For one thing, they don't make these anymore, so we're trying to save the cylinders a little bit. We don't weigh nearly what they did in combat. We're probably 20,000 pounds lighter than they were when they took off with a load of bombs. So we really don't need it. And in addition to that, the only fuel available today is a lower octane than they were able to use during the war. During the war, they had 115 to 130, 145 octane fuel sometimes, a lower detonation capability. With the 100 low lead fuel that we have today, the possibility of detonation is always there, ever present. So we just back it off and we use 41 inches of takeoff power. And that's a supercharger. The gearing is in the nose case, and it's a planetary style gear system, and it's a 16:9 ratio. Write all this down, it's going to be on the test. 16:9 ratio means that it's almost half. So if the engine's turning 2,000 RPM, the propeller's turning about 1,100 RPM. This does 2 things. By speeding up the engine, it produces more power. By slowing down the propeller, it's more efficient. So now you know everything there is to know about the Wright Cyclone R1820-97. There are 2 things, there's only 2 things that are hydraulically activated on this aircraft. It's basically an electric airplane. It's one of the first. So for 1935, this design was pretty amazing. The only things that are hydraulic on this airplane are the cowl flaps. In this position, they're closed right now, but we hydraulically can open them. Since the engine is air-cooled, we can open those a little bit and modify the amount of airflow through the cowling to get better airflow or reduced airflow by closing them. And those are hydraulic. And the wheel brakes. And the wheel brakes are just like any other brakes. And they're toe brakes. They're on the top of the rudder pedals. And they're hydraulic. Everything else is electric. The landing gear is electric. The bomb bay is electric. The flaps are electric. And a lot of stuff on this airplane. The landing gear, each landing gear has its own motor. It's a 28 volt DC motor with a jack screw. And that 28 volt motor runs a jack screw and runs the gear over center. But each one has its own motor. Our airplane and the design that we have it in, the configuration, we do not retract the tail wheel for maintenance purposes, and also because the tail wheel, when it retracts, it brings itself up into the room, the aft in front of the door, which we'll go to, and we don't want that to hurt anybody or hit anybody, so we leave the tail wheel down for that all the time. But each motor, when we put the gear down, each motor operates and turns that jack screw. And the flaps are a 28 volt motor with a jack screw, and the bomb bays are a 28 volt motor with a jack screw. If for some reason we have to crank the gear down, it is about 269 turns. The real answer is how many turns does it take? As many as it takes when you crank it till it stops. But the short answer is 269, give or take. And that's the landing gear system. It sticks out a little bit. If you'll notice how big these tires are, they're very huge diameter tires, and they were supposed to be designed to be to land and take off from unimproved airports, and that was one of the benefits of that. The retractable landing gear was still a novice idea at the time. They weren't ready to go all the way with it. So if in flight, this airplane, the landing gear will stick out about to here. It goes up and sticks out about this much. And what that is, that gives it an emergency landing platform, if you will. If it has to land with the wheels up, it's got something to help cushion it. And that's what the landing gear is for. Let's step out here in between these engines. So the engines are numbered 1 through 4 starting on the left. So the outboard left is number 1, inboard left is 2, this is number 3, and that's number 4. In between 1 and 2 and 3 and 4, you see 2 more big holes in the wing. Those are the oil coolers for their respective engines. This is the engine oil cooler for number 3. This is the oil cooler for number 4. The oil tank, step over here. Oil tank for number 3 is up there in the wheel well. This black tank right there. That tank holds 37.5 gallons of oil. Yes, gallons. 37.5 gallons times 4 engines. The airplane itself holds 1,700 gallons of fuel, 1,700. In combat, they had extra gas tanks. They were called Tokyo tanks. They were mounted out in the wings and between the ribs, further outboard of 1 and 4. And those were called Tokyo tanks. And the combination of the main tanks that are in here plus the Tokyo tanks almost doubled the fuel, over 3,000 gallons that they had. It gave it a lot of range. Typically it burns about 200 gallons an hour, and it probably burns about a gallon of oil each an hour. So this is not your Prius by any stretch. While we're talking and out here by the engines, I will show you that supercharger that we don't use. Again, it's an integral part of the exhaust because this is the exhaust stack. On engine number 3, it comes out the side and has to go past the landing gear and back around to get out. But on 1 and 4, it can come straight down. This is the exhaust, goes through the turbocharger, and then if it was actually going to be used, there's a shaft that goes up and an impeller that compresses air and puts it into the engine. That's why they had those cooling things. So this is the turbocharger, and it would have a wastegate over here that we would control from the cockpit how much turbo we needed, and it would just deflect the exhaust. Instead of coming out the regular exhaust, it would be forced through the turbocharger and spin it faster the more exhaust comes through there. Those little vents sticking out there, those are the fuel tank vents, and that by having those facing forward like that puts a little positive pressure on the fuel system for higher altitude flight. Up here we see a couple of holes in the wing. All of the gas tanks in the wing, each engine in this airplane has 425 gallons of fuel behind it, and the most typical fuel system that we have is tank to engine. So number 1 has its own supply of fuel, number 2 and 3 have their own supply of fuel, and then number 4 has its own supply of fuel. 2 and 3, because the landing gear kind of breaks up the nacelle, they have to split that 425 gallons into 2 different tanks each. So there's a total of 6 physical gas tanks on the airplane, but there's only 4 schematically, and each is 425. They are self-sealing bladder style tanks, and the self-sealing is a little bit of a misnomer. They didn't totally seal it off, but they did slow it down to a dull roar if they did get shot. Same with the oil tanks. You saw that black coating on there, that was a self-sealing on that. these holes here are to ventilate the wing, and that's just to keep air. So if you were to get a bullet hole in a gas tank back there and they get a lot of fuel vapor back there, you can imagine the disaster that could create by having exhaust and sparks and flames all around. So by opening up this wing, it's huge in there. You could almost hold a dance in this wing. But it ventilates that, and when we get around to the back side, you'll see some louvers on the back side of the engines, and those are exhaust louvers. So air comes in there, circulates around, and is exhausted before it can make any kind of a fuel problem as far as exploding. So, and we got a landing light. Now, this airplane does not have leading edge boots on it. For those of you unfamiliar with leading edge boots, they are a de-icing mechanism, and it uses the other side of the vacuum pumps, and it pumps air out here, and those are actually would be rubber boots on the leading edge of the wing. And when we decide to blow the boots, you wait till it gets a pretty good supply of ice on it, and then you'd open that up, and the boots would inflate, and it would throw all that ice off, and then you'd be back and then wait till it build it up again and then do it again. The idea being that you just did that to get through the icing problem, not to stay in it and continue flying. But at EAA, we do not need to be flying in any kind of weather like that. It does not have the boots. It does have the ceremonial paint that looks like a boot, but it does not have the de-icing boots on it. If we're in icing conditions, there's a happy hour that we're missing somewhere, and we are going to be at it. So we do not fly in icing conditions. So that's what we got there. If the airplane had been equipped with Tokyo tanks that we talked about earlier, they would be between these ribs, and those are vent holes for those Tokyo tanks if they happen to be installed on the airplane. What have we here? This is an aileron. Now it's locked right now because we have the controls locked, and I can't move it down here to show you very well. But if you will look, let me go over here where it's a little less dihedral. This is fabric. All of the primary flight controls on this aircraft are fabric. The ailerons, the elevators, and the rudder are all fabric. It was the method of construction in the day. It's very lightweight, and it takes a pretty good beating. It was easy to make them. Flight controls have to be balanced correctly. If they're not balanced correctly, they can flutter. If they flutter, it is tragic, the consequences of that. So they knew how to do it with the fabric. Not to mention, if a bullet goes through that, what have you really done? You cut off a piece of your shirt, you glue it on, and you're good to go. So it was a pretty simple fix most of the way for maintenance-wise. In today's environment, very few airplanes are fabric anymore. A lot of home builts are. But this was the method of construction during the day, and it was lightweight, and it was a lot lighter than and easier to work with. So these are the flaps. I mentioned earlier they are 28-volt DC motor with a jack screw. When you put those down, an interesting thing about the B-17 flaps is they're not the flaps that you would see on the 737. If you look out the wing, you almost see the wing come apart when it comes out in sections. This is called a split flap. If you look at it, the wing doesn't move, only this part here, and it splits, it comes down like this, 45 degrees. Hinges here and opens here, but the top doesn't come down, just the bottom. So they're mostly drag flaps. They are used a little bit for lift. For a shorter field takeoff, you can use 15 degrees of flaps, and you will get off quite a bit shorter. We don't normally have to do that because we don't usually go into runways that we need that kind of extra thrust or extra lift to get out of, unless we're real heavy or something. We're pretty heavy right now. We came down here full of fuel, so it's got a lot in it. If we go up on top, those are those exhaust louvers I was referring to. exhaust louvers are what allows the air to circulate through the wing and save the wing from becoming full of fuel vapors. The gas tanks, there's 3 on each wing. The outboards are individual tanks of 425, and then the inboards are 2 different tanks split into a total of 425. And it's something like 208 and 213 or something like that, but it equals 425. Higher math. As we come around here, this is how the maintenance guys get up on the wing to fuel it and do the maintenance, stuff like that. This is the ball turret. The ball turret is electric mechanical. It's got its own power supply. And this is the entrance to the ball turret. Now, contrary to popular belief, you do not have to be the smallest guy in a crew to work in this environment. You have to be about the craziest, however. I've actually been inside this and I fit. It wasn't pretty, but I fit. This is the opening for it. So they did not get in this on the ground for takeoff. They would be in the back, sitting on the floor. When he goes to get in his position, which is usually out over the channel on the way when there's any kind of threat of enemy aircraft, everybody would assume their positions. He has to turn it so that the barrels of the guns are pointed straight down, and then he climbs in this hole from inside the airplane. And once he gets in there, then he gets all set up and he looks kind of like this is where his back is. Self-generate. He makes his own electricity, and well, they use electricity, but it's got a hydraulic, spins around, and that's where he is. Can you imagine sitting in that for 8 and 10 hours at a time? I think not. Interesting factoid, believe it or not, this was actually one of the more safe positions statistically on the airplane. The statistics are, well, first of all, this is armor plated. Plus you're rolled up in a ball, you're a very small target. And this particular space was one of the most safe positions to be in. The waist gunner was the least. We'll talk about that now. The G model, one of the changes in the G model was it actually did have this plexiglass covering on the waist guns. The earlier models had several variances. Some of them had a metal plate that would cover it up, and they would actually bring the guns inside and cover that plate up, but then they'd have to open that all up and bring the guns out to use them. So by doing this, they have a single 50 caliber machine gun, and it's covered in plexiglass, which is a little bit of a respite from the 30 below zero and 200 mile an hour wind. How many people can actually say they got a key to a B-17? I got one. I don't know if it works. There we go. This is the main cabin door. The main cabin door is where most of the enlisted would go. The crew on the B-17, the general crew in the standard environment was 10. There were 4 officers, the pilots, the navigator, the bombardier, and 6 enlisted. And they would be the radio operator, the flight engineer, the waist gunners, the tail gunner, and the belly turret. This is where the enlisted would probably board the aircraft. The tail wheel, we talked about it already. It does retract up inside. It also has a 28 volt DC motor with a jack screw. The tail wheel, for those of you aviators, is non-steerable. It just swivels like a grocery cart, sometimes a little too much like a grocery cart. But we lock it. It's lockable for takeoff and landing in a straight position. And then when we're taxiing, it's usually unlocked and it just follows along like a grocery cart. Again, we have the black simulated stabilizer boot. Now, an interesting factoid, the stabilizer is a symmetrical airfoil. And the reason it's a symmetrical airfoil is Boeing had very limited space in their factory. They did not know, I mean, this is a big airplane. For 1935, this is huge. 103-foot, 9-inch wingspan. What they did was, these are all symmetrical so they could be interchangeable left and right. So they just built stabilizer sides, and it didn't matter whether they went on one side or the other, they're symmetrical, which is pretty cool. Pretty neat engineering. Over here, this is the bailout door for the tail gunner. You can imagine at 30,000 feet on oxygen, 30 below zero, getting shot down, trying to find your way around the big bulge in there where the tail wheel goes, find your way out the door. So they put a special door in there so he could get out in a hurry on his own. We're walking around here. Here's another pretty good example of the fabric flight controls. There were 12,731 of these built. About half of them were G models. Of that 12,731, Boeing themselves built about half. Douglas built about a quarter, and Lockheed Vega in Burbank built another quarter. It's very weird, but this happens to be a Vega built Boeing B-17. It's a little bit akin to Ford Motor Company building Chevys during the war. Everybody pitched in. The Boeing company was pretty much obsessed with their B-29 because it was an up-and-coming airplane. So they farmed this work out to Vega and Douglas, and they built, each of them built a quarter of them. This particular one is built by Vega in Burbank, California on May 18th of 1945. I mentioned earlier it was too late to see service. It was made about, 10 days after VE Day and about 2 months before VJ Day. So it never saw service. It did do high altitude aerial mapping in the Middle East back in the 50s, and believe it or not, it dusted for fire ants in Louisiana and Alabama in the 60s. So more fabric controls. The elevator trim, very, very sensitive. Amazingly enough, it takes movement on our wheel up there, that much right there will make a lot of change. This is the tail gunner position. This poor guy has been in here for the 3 years I've been flying this airplane. He's been in that seat and hasn't gotten out yet. But that's a pretty good view of the mannequin there. This is actually, this modification here is actually called a Cheyenne tail. The Boeing tail that they first put the tail guns in was an afterthought. They were getting shot from behind, so a couple guys out in the field started putting machine guns in the tail, and then Boeing said, hey, that's a good idea. So they built one, but it was very antiquated, very cramped and all that stuff. So they came out with a Cheyenne tail. The word Cheyenne is from Cheyenne, Wyoming. Boeing on the assembly line did not want to mess up the assembly line by making a lot of changes. There were over 400 changes from the first B-17 through the last iteration of the G model. So what they did was they would just fly it, make it the way, whatever they made it on the assembly line, and they'd send it out to Cheyenne, Wyoming was one of the places. That was a heavy maintenance United Airlines maintenance facility there, and they had a contract. So they would bring the airplane to Cheyenne, and the Cheyenne employees would unrivet that row of rivets right there and some other things, and this whole section would come off, and they would take that old section off and put on this section, and it has more conveniences, a better sighting system. It still has the twin 50 caliber machine guns, but this was called the Cheyenne tail. So it's got a lot more room in there, a little better seat. The original seat was like a bicycle seat, very uncomfortable, and especially at 8 hours and 30 below zero. So the Cheyenne tail, again, we come across the other side. The rudder, if you can kind of get an idea how large the vertical stabilizer is compared to the rudder, even though the rudder seems to be large, it's pretty much useless at lower speeds. It doesn't do much because it's compared to the size of the fin. The only flight control that has assist on the aircraft is the rudder. It has a balance tab there, and what that does is when we move the rudder to the left, that tab will move a little bit to the right to give it some aerodynamic assistance so it's not quite so heavy on the rudder. It also is the rudder tab if you were to lose an engine and have to adjust a little bit of rudder trim in there to compensate for that. That's what that tab does. But it's also a balance tab. And for those of you who are pilots, the rudder is very ineffectual on this airplane just because of the size of the vertical stabilizer. I mentioned earlier the 13 machine guns on the aircraft. They're all 50 caliber. The only one that we have missing and is the one that is in the radio room. If you look at that hatch slightly behind the rotating beacon up there, you'll see that hatch there. That was designed so that the radio operator could drop that hatch out and swing a single 50 caliber out the back and shoot. They stopped using them after a while because they had so many people in formation that you couldn't shoot anything without shooting somebody or your buddy. So they stopped putting those in. For recognition purposes, this is the door we talked about earlier, the one I unlocked, and the crew would crawl in here. These chairs look like they might be authentic, but they're really not. They did not have any of this in here. That was strictly just the floor. And when the crew took off for a mission, they all just sat back, all the enlisted guys would just sit back here on the floor. I mentioned earlier the tail wheel and why we leave it extended. The Experimental Aircraft Association has a limited exemption, and we're allowed to carry passengers on a non-passenger aircraft is what it amounts to. Part of our seating is these two seats back here. The tail wheel, if and when it retracts, comes forward like this into this room. So by locking that down and putting plexiglass there, it protects people. It's a safety issue, and we leave it down, and this is a seat for two passengers here. Back behind here would be where the tail gunner goes, and he's way back there. It's a long way for him to walk and crawl, but that's the whole story there. Again, these seats were not here, both here and across the way, but our limited exemption lets us put some passengers in these seats, and as soon as we get in the air, they're allowed to roam around all over in the airplane. As you can see, there is no insulation. This is a 1935 design, no insulation. That skin right there is hot because the sun's on it, and it's there's nothing to prevent any kind of cold or heat from coming in here. The main flight controls to the tail are right here over my head. These are the aileron, or excuse me, the elevator and the rudder, and the elevator trim and the rudder trim. These are the cables that go back to the tail, and there's nothing protecting them. So we've made this a little nicer to get people to be able to walk on some stuff here. And again, we have some seats across here. These are the waist guns. If you'll notice, they're staggered slightly. In the earlier models, the very first models, they were not staggered. And you can imagine trying to fire this gun next to this guy and both of you getting in each other's way. So your butts would be rubbing together and that wouldn't be so good. So they staggered them in the later models. Now the good news is they had a piece of armor plating. This is 1/4 inch steel right here. And so is this over here. So the waist gunner had a little bit of protection, but when they staggered the guns, they didn't put any protection from behind. So there was nothing there. This is 25 or 32 thousandths skin, and it won't stop an arrow, much less a bullet. So this is the waist gunner's positions in flight. These are the magazines that the 12 yard, or excuse me, the 9 yards of ammunition would go into. 27 feet of ammunition would be zigzagged through here, and these belts were all loaded by ground crew after they returned. If they returned from the mission, they would be reloaded by the ground crew back at their base. You have intercom. You have their oxygen demand system. So they had the oxygen tanks all over in the airplane, and this particular tank is for the ball turret, and he has to have kind of his own separate one because he'd be twisting it all around in flight. So these are the oxygen tanks and their gauges to make sure they have oxygen. Think about being at 30,000 feet. It's 30 below zero. You're an 18-year-old kid, first time away from home. If you lose your oxygen supply, you got about 30 seconds of useful consciousness, and that is not good. These are they wore heated suits. That was kind of a new technology as well, and a lot of guys didn't use them. These were the plug-in positions for that, and it's just like a plug in your house, and then you had the amount, how much did you want, how hot did you want it. But they were notorious for shorting out. If you get all dressed up and put these suits on and it's like this outside, you're going to be sweating, and when you're sweating and you're climbing to 30,000 feet, well, guess what? Water and electricity don't mix. This is the remnants of a trailing link antenna, so the radio guy could actually run an antenna out behind the airplane a couple of 100 feet to get a hold of the home base or whatever he needed to talk to. You have some oxygen cylinders there, and then this would be this waist gunner's ammunition compartment here. This is the aforementioned ball turret, and he would spin the guns down, and then the hole that we opened up on the outside would be right here for him to climb into. This airplane is built kind of like a mini condominium. There's just all kinds of different places to put things. I'm going to take this out only because I'm hot. And this is the cover that the radio guy could take out, and he could bring a gun from this position out here and fire up and away. This is a radio man's position. They had a couple of seats over here, so if they didn't want to sit back there with their buddies, a couple guys could sit here. But most of this whole entire room is radios and radio equipment and oxygen. These are also the controls. As we continue on, we go across the spar here, the rear spar. This is the catwalk, and we're now in the bomb bay. Easily identified by the bombs. The bomb bay was just that catwalk through there, through that V, and those guys were a lot skinnier and in better shape than I am. This is the forward spar right here. The airplane would, on a typical mission, would carry between 4 and 10 or 12,000 pounds of bombs each. The poundage would be predicated on the length of the mission. If you had a 10 or 12-hour mission, you had to carry the extra weight in fuel, so you weren't able to carry as much bomb load. The closer the mission, the more load of bombs you could carry. This spot we're standing in right now is the top turret flight engineer area. In a real airplane, this is a real airplane, but the one, if we had this in here, this is kind of the milling about spot where everybody wants to go down to the bombardier and navigator stations. So it would be very awkward to have the entire assembly for the flight engineer sitting here. But he would sit on almost a bicycle seat, much like the tail gunner, and that's how he would sit and aim and turn, and he would himself turn around inside this cage to protect the other aircraft behind the cockpit crew. His job was this top turret. He was also the guy that had systems knowledge, and he would fix things. He would be the guy cranking the landing gear down if necessary, and the guy that was monitoring oil pressures and temperatures and stuff like that. So these seats were not here either, but these are our crew chief sits in one, and then a passenger will sit in one when we take off. This is the cockpit. It's pretty standard and it's pretty original, except for the modern radios. In this day and age, it's almost impossible to get by without having some modern radio technology with the airspace issues that we have today. So here we are in the business end of this thing, my business end anyway. I'm not a bombardier, so I fly the airplane. Obviously the captain's going to sit in this seat and the first officer's going to sit in that seat. This is the view from in here, and it's a spectacular view no matter how you slice it. It's a standard airplane. It has rudder pedals, elevator, and ailerons. Ailerons are extremely heavy on the aircraft. The elevators are almost too light, and the rudder is somewhat in between, but it doesn't do much. So we got that. Basic flight instruments are modern equipment. We have an attitude indicator. They had attitude indicators in the war. They would have a big one. They were about this big, and they would be in the middle so that both guys could see it. And ours is redesigned slightly so that we have modern equipment. If we do have to shoot an instrument approach, we can do so. We talked about the cowl flaps earlier. These are the cowl flaps levers, and we can open one if we want to open number one. We just open it like that, and you see it open out there on the cowling, and then we close it and lock it, or we can close it. And the reason we're able to do that right now without engines running or electrics running is it has an accumulator. The hydraulic system is an electric motor. It doesn't run off the engines. It runs off of an electric motor on demand. So right now we're showing about 700 pounds of pressure in the hydraulic system. After the flight instruments, this is the way it was during the war. The first officer had all of the engine instruments over on his side, and you can see they're pretty basic. They had some good size oil pressure indicators and good size oil temperature indicators. And those are kind of important on this. The rest of it, the boost pumps, these are the mixtures, and please note that they are backwards. So in most airplanes, pushing forward would richen the mixture. In this aircraft, this is idle cutoff, and then this is auto lean, and this is auto rich. But in this airplane, in the B-17, it's backwards. It's actually, this is cut off, and it takes a little getting used to. These are the propellers. The propellers are Hamilton standard 3-blade, and they are oil controlled They use oil pressure to control both sides of the dome to run their constant speed propellers. So this is how we adjust the speed of each engine. And in flight cruising, they're somewhere down in there, because we set them back to cruise at about 1900 RPM. These are the throttles. I would dearly like to find a guy that designed these and hang him, because they can be kind of a problem. So what we have here is 4 engines. If you want to do all 4 at the same time, it's these 4 here, because you get, this is 1, this is 2, this is 4, and this is 3. And or you can do 1 and 4 only, or you can do 2 and 3 only. But to do all 4 of them at the same time, you have to do this, and you have to do it underhanded. And I heard that this whole technique came from the Boeing Flying Boat Model 314, where they had them hung over the side, overhead like this, and they just used that same engineering for this. So those are the throttles. Control locks, the tail wheel lock. This is a control lock here. Right now they're in the lock position. If I was to push that down, now the flight controls are unlocked. The rudders and the elevators are unlocked. And then the aileron, again, the A-team of engineers was off the day they designed this, but this is the aileron lock. It works. It all works pretty well. And to lock those again, is center them up and then push the wheel forward, and it's locked. The tail wheel lock is on the other side, and the first officer is responsible for that. Usually the captain or whoever's flying will call for unlocking the tail wheel or locking the tail wheel before takeoff. So they're responsible for that. Interesting side note about this airplane and the systems is the operation that the pilot cannot do is the parking brake. The first officer has the parking brake to set. It's that red knob underneath the lowest red knob. There is the parking brake, and the only one that can set that is the first officer, and the only one that can release that is the first officer. Even if he sets it, I got to wait for him to unlock it. It's a very strange deal. Conversely, I get back at him because the only one that can adjust the aileron trim is the captain, because it's over here. They didn't spend a lot of time working out what would be feng shui, if you will. They just kind of put it wherever they needed to go, and you had to deal with it there. I mentioned the landing gear is electric. This is our landing gear switch and the flap switch. Originally, the landing gear switch and the flap switch were right next to each other. Again, not a very ergonomically great place, so we moved it up there for safety purposes. The electrical panel is all over on the captain's side. So we got battery switches and inverters, generators, amp meters. Everything is over here on this side. The propellers can be fully feathered. If we were to lose an engine and have to shut one down, we actually turn the propeller 90 degrees to the airflow outside so that it reduces the drag on it. And by reducing that drag, it gives you a fighting chance to fly on 3 engines. But we feather it with these buttons up here in the overhead. So if number 1 were to fail, were to quit, we would verify that, yeah, it's number 1 by pulling back the number 1 throttle. Then we'd verify it further by pushing the propeller control all the way forward. And then we'd verify it further by going to idle cutoff on the number 1 mixture. And then when we're sure, yeah, that's the one we want, then we'll reach up here and push that button. Well, welcome to the forward condominium. If you look over on the side there, you'll see that door that we first started at. That's the Gregory Peck door, the crew entrance door from the outside that we started with this whole project, just for reference on where you are. Now you've come into the bombardier and navigator condo. I'm sitting in the bombardier's chair right now. If you go for a ride in this airplane, this is the chair everybody wants to sit in. But before we start with that, this is the navigator's table, and this is that's an example of an airplane that made it back from combat and got all shot to heck. But the navigator's table there, and that's where he sat. And these are these two cheek machine guns that he's responsible for. He was responsible for these very narrow band of shooting he had. And then this is the bombardier's control panel. So he could change the gun sights and all this stuff. And this is a salvo switch to dump all the bombs. And this is the regular dropping switch. But he had flight controls up here. This is the Norden bomb sight, and his eye would go down on this, and he would make small adjustments, and they're gyro stabilized. That was the big thing that the Norden bomb sight had, because without that, the airplane pitch up, pitch roll left and right. You could be miles off course with your sights, just because you're at 30,000 feet, 6 degrees up or 6 miles up. So by having the gyro stabilization, it centered that a whole lot and made it a lot easier. So if the bombardier was sitting over here like this, in his chair with his head down, very awkward, this is the flight control, or the control for the guns on the bottom. He swing this over, he had a sight, and he could fire it, and he would up and down, and left and right. And then these are his ammo boxes. But you can actually, as you can see, you can stand up in here once you're through the passageway. It's amazing.